electrocardiography. So in order to understand ECG, you should know what is the basic concept behind ECG. See, in ECG, there are certain electrical activities which is happening in the heart. In the heart muscles, there are some electrical activities which is occurring in the heart. You should first study what are the electrical events or what are the electrical activities which are occurring in the heart, in the musculature of heart, right? And next is the how these electrical activities or electrical events which is occurring in the heart is converted into vector, right? And third is we will be discussing how this electrical vector is converted into the graphical pattern, right? Okay, in simple, ECG is defined as they are the pattern or the electrocardiograph means the electrical activities of the heart is graphically represented. Simple definition. There are the electrical activities which are occurring in the heart are graphically represented, which is called as an electrocardiography. So what are the electrical activities which is occurring in the heart? So today's classes we will be discussing what electrical activities are occurring in the heart, right? Okay, first is so I am drawing one. Right. See, imagine this is one myocardial cell. I am drawing one cell. I am drawing one myocardial cell. Right. So this is one myocardial cell, right? And this is second myocardial cell, and this is third myocardial cell, right? So I am drawing the cell, one cell. Suppose if you take this is the heart, right? So I am taking a piece of muscle and then I am drawing here, right? So this is this is atrium and this is ventricle. So I have drawn the three ventricular myocardial cell, right? This portion, right? So this is first myocardial cell, this is second myocardial cell and third myocardial cell, right? So what is, okay, so do you know what is the resting membrane potential of the cell? What is resting membrane potential? So I have drawn the ventricular cell, three cell myocardial ventricular cell I have drawn. We are going to study what electrical activities are occurring within the cell, right? So first you should know what is the resting membrane potential. What does it mean, resting membrane potential? And what is it? Kitna hai? How much? Okay, they are not here. Kitna hai? Resting membrane potential normally kitna hai cell ke andar? Yes, minus 90 millivolt, right? If the membrane potential is minus 90 millivolt, then it is called, then the cell is said to be resting. That is, it is not contracting or it is not related, it is rest, in a state of rest. Or in other words, how this 90 came, they are the electrical differences, right? It is an electrical difference. Resting membrane potential is in resting condition when the electrical difference, potential difference between inside the membrane and outside the membrane. It is a difference, electrical difference, potential is it's a difference in potential between inside the cell and outside the cell. That difference is minus 90 millivolt. That is called resting membrane potential, right? So this is minus 90 millivolt. Imagine it's minus 90 millivolt, right? And when the muscle is stimulated, when the muscle is stimulated with appropriate stimulation, right? Some amount of sodium or cations, positive ions will trickle into the cell. So sodium, normally sodium in extracellular is excess. When appropriate stimulation is given, right, some sodium will trickle into the cell, that is positive ions, right. So minus 90 is the resting membrane potential. When positive ion enter, what will happen? It will go to the threshold potential. Slightly the membrane will become positive, right? From minus 90, imagine when it reaches 70 millivolt, right? So that is called the threshold potential. When the resting membrane potential reach threshold potential, that is minus 70, what will happen? Some channels get open, right? Some channels, they get open, and they are called voltage gated channel. Voltage gated channel will open, and more sodium will enter. Are you clear? First the cell is resting, that is minus 90 millivolt. What is minus 90? It is a resting membrane potential. It is a potential difference between inside the cell membrane and outside the cell membrane. That difference in potential is minus 90 millivolt in myocardial cell, right? When the muscle is stimulated, appropriate stimulation is given, some amount of sodium will enter into the positive ion will enter into the cell, which will take minus 90 to minus 70. When it reaches minus 70, at this point, some channels will open. Sodium channels will open, and these channels are called as voltage gated channel will open. So because this voltage gated channel was open, more and more sodium will enter into the cell because extracellular sodium is high. More and more sodium will enter. So what will happen? Minus 70 will become minus 60, 50, 40, 30, 20, 10 and 0. Right? Because sodium is entering, more positive is entering into the cell becomes, previously it was negatively polarized, now it reaches 0. Right? Or in other words, the cell is, previously it was negatively polarized, now the cell is depolarized. This we call it as depolarization of the cell. Right? So what does it mean? Depolarization means, depolarization, how it happen? When minus resting membrane potential, when it reach threshold potential, sodium gated channel open, more and more sodium entered into the cell, and the cell now it becomes depolarized. Previously it was negatively polarized, now it is depolarized. When it reaches 0, sometimes it reaches positive also, plus 10 also, right? Sometimes it crosses beyond 0 also, right? And now what happens? At this point, the few more channels are open, and they are called as okay. So now few more channels are open, right? And they are called as right. This channel is called calcium channel, and this channel is called potassium channel, right? And these channels are called as depolarization sensitive channels. Right? What are the depolarization sensitive channels? Calcium channel and potassium channel. These channels are called as depolarization sensitive channel. So when it will open? When the cell is completely depolarized, at this point, right, these channels will start opening. Are you clear? So, inside potassium, intracellular potassium is high and extracellular calcium is high. Right? So now what will happen? Calcium will start coming in and potassium will start going out. Right? So depolarization sensitive calcium channel and potassium channel. Previously it was closed. When it will open when the cell has become depolarized. Hence those channels are called as depolarization sensitive channels. Right? Now the cell is gaining positive ions, positive, and losing positive. Calcium is positive, right? The cell is gaining the positive calcium ions, and cell is also losing the positive potassium ions. So for a period of time, there will be no potential difference or change in the cell. The net potential will be same for a period of time because cell is gaining positive, losing positive. So for a period of time it will remain zero. Right? After some time, what happens? The calcium channel closes. Only potassium channel, more and more potassium channel is open. Now, calcium channel what happened? Calcium channel is closed and more potassium channel is gate for potassium is open, right? So now what will happen? The cell will lose what? Potassium. So the cell is now losing the positive charges. So again what will happen? The cell will become negative, or the cell will become back to its negative polarity. So this event is called as repolarization. Right? Previously depolarization means the cell is normally polarized negatively at rest. Normally it is polarized negatively, so at rest, right? When the cell is becoming positive, we call it as depolarization because the cell is losing its polarity. So we call depolarization. And when the cell is losing the potassium and again it is coming to its original negative polarity, we are calling it as repolarization. Any doubt? Okay. Again I'll repeat. The cell is negatively polarized -90. When you give appropriate stimulation, some amount of sodium, only small amounts of sodium will trickle into the cell, will enter into the cell. When it reaches 70, so if it is not reaching 70, then these channels will not open. It should reach minimum threshold level, that is -70. That much sodium should enter into the cell. Right? When the resting membrane potential reach 70, then sodium channel will open and more and more sodium will enter and it will become zero. Right? And when at this point other channels also open, sodium and potassium and calcium channels open for a period of time, both the channels remain open for a short period of time. Right? Calcium enters, potassium loses. And for a period of time, the net potential difference is zero. And after some time, calcium channels closes and more potassium channel opens. Potassium is leaking out the cell and the cell is repolarized. Right, so this is the first electrical event occurring in one myocardial cell. Right, and second is when the first when the first cell is depolarizing, see there are some windows are there, right? Between each and every cell there is a window which is called a gap junction. Each and every cell is having a connection, right? Window cell, or it is a gap called as a gap junction, right? When the sodium, when first cell was depolarizing, when the first cell was stimulated, and when sodium is entering into the first cell, some amount of the sodium will enter into the second cell also. At the time of depolarization of first cell, only this cell we are stimulating. We are not stimulating second cell, right? But when sodium entered the first cell, some amount of the sodium also entered into the second cell. So what happened here? Minus 90 has become minus 70 in the second cell, right? So when it is reached minus 70 millivolt, what happened? What channel open? Sodium channel open. Sodium will enter and it will reach to the zero, right? And at this point, some more channels open. What is this called? Calcium channels and potassium channel. Calcium came in and potassium went out. For a period of time again, net potential is zero, and more potassium channel open. So it comes back to repolarization. So when this cell was stimulated, again some sodium entered here. Same thing happened here also. So depolarization and repolarization are moving from one cell to another, and this process is called as action potential. This is called action. Action potential is the cell is the repolarization and depolarization is occurring in this direction. So action potential is moving in this direction.